Hey there, friends and neighbors. I'm going to show you now how to read the statistics decision tree spreadsheet that I made and shared for the class. This spreadsheet helps you decide which inferential statistical procedure you should use for any type of data that you might be presented with in an introductory or intermediate level statistics class. A good rule of thumb, if you have two possible techniques that are both appropriate, you should use whichever one is simplest. There are two main inferential statistical procedures. Those are hypothesis tests and confidence intervals, and this covers all of them. This teaches all of the techniques that you would need for this level of class, intermediate or basic. Okay, so the first question you ask yourself is how many variables you have. Once you've answered that, you need to identify each variable's type. If you have two or more variables, then one of them is most likely an input and the other is outcome. You need to decide which is which. And then if you have a categorical input, we need to know if they are repeated measures or if they are independent samples. Once you've made those decisions, you will have narrowed it down to, in other words, you have made a decision about which statistical procedure to use. So this basically covers all the inferential stats you need. Let's do a few examples. So first, Team Mortonians wants to know about library kiosk use at Centralia College East Campus. So they take a simple random sample and they ask people one question. How long have you known about the kiosk? And they gave two options, less than 6 months or 6 months or more. They want to know if over half the population has known about the kiosk for more than 6 months. That's their hypothesis that they want to test. Okay, so let's go to the decision tree. How many variables are there? Is it one variable, two variables, or three or more? Well, they only have one variable here. Their one variable is how long have you known about the kiosk? And it is categorical, less than 6 months or 6 months or more, so there are two categories. So already I've narrowed it down to one variable. It is a categorical variable, and they are two groups. So I'm going to highlight these, and these are the two possible options. The parameter I'm estimating is a population proportion, and I can either do a z-test for a hypothesis test or a chi-squared goodness of fit test. And to estimate the parameter, I would use a confidence interval with a z-distribution. The simpler procedure is the z-test, and if you're early in an introductory statistics class, you will not have heard of the chi-square goodness of fit test yet. So we would go with the z-test typically for this if we've only got two groups. But either is technically appropriate, and they really are mathematically identical. The main assumptions, well, first of all, there's always a freebie assumption. For every statistical procedure, we always assume that observations are independent for every inferential statistical procedure that we will cover in this class. Okay? And so I'm assuming that n times p is at least 5, and also n times q is at least 5, where q is defined as 1 minus p. Equivalently, we call these np and nq, in general, we call them expected values. So if we assume all expected frequencies are at least 5. If they are not, if that is not the case, then you really shouldn't be doing this procedure and you should stop. But for purposes of an introductory class, it's enough to just be able to recognize the assumption, do the simple computation, and answer the question of whether or not you meet the assumptions. Where can I go to read more about it? Well, I can go to, in OpenStax, section 8.3, or in Triola, chapter 7 or chapter 8. How do I do it in R with R Commander and the EasyR plugin? Well, I go statistical analysis, discrete variables, one sample proportion test. Looks like this. Statistical analysis, discrete variables, one sample proportion test. You click on it. You choose your categorical variable. Let's say this one. Choose chi-square test. Turn off the exact test. Set no for the continuity correction. Set your hypothesized proportion. Set your alternative hypothesis. I'm going to make it 2 tail 0.5. And then you click OK. That's how you do it. Let's do another example. Here again with Team Mortonians. This time they're going to ask people, how long have you known about the kiosk? How many weeks? And they want to know if the mean number of weeks is more than 24. So going to our statistics decision tree, I say how many variables is it? There's one variable. So I don't need to know about two. All right, there's one variable. and that is number of weeks. So is that quantitative or categorical? It is quantitative. So you're down to 3 options. Let's go over to the right, shall we? Now, am I estimating mu or sigma? I am estimating mu, the population mean. Do I know the population standard deviation? No, I do not. So I would not use a z-test. I use a t-test because sigma is not known. So, to test the hypothesis, I would use a t-test. To get a confidence interval, I would use the t-distribution. My main assumptions are that n is at least 30, n is large, or the variable is normal, or both, and that all groups are independent. I can learn about it in section 8.2, or in Triola I can learn about it in chapters 7 and 8. How do I run it in EasyR? Statistical analysis, continuous variables, single sample t-test. It looks like this. Statistical analysis, continuous variables, single sample t-test. And then I choose my variable, let's say grade. I choose my population mean, hypothesized, let's say 65, and one tail, left tail, or right tail, or two tail, left tail, or right tail, and click OK. And there it is. Let's do another example. Pink Dogs is helping a local high school learn about drug use and familial drug use at their school. They take a random sample of students. They ask them 2 binary questions. Have you ever taken drugs, and has anyone in your family abused drugs? They want to test the claim that personal drug use is related to familial. That is exactly like saying they want to test whether the proportion of students who have used drugs is the same regardless of whether or not their family has abused drugs. So let's go look at that. How many variables is that? Well, that's 2 variables, personal drug use and familial drug abuse. The outcome variable would be personal drug use, because that's what they're predicting. So is that quantitative or is that categorical? That's a categorical variable. How many categories? There are 2, yes or no. So this or this. Okay, the input variable. Is it categorical or is it quantitative? It is categorical. Familial drug use is categorical with 2 categories. Are those categories independent? Well, each person in their response set either does the thing or does not do the thing. There's no repeated measurement. Nobody is in both groups. So that means it's 2 independent groups. So one of these options. Now, get up here. So my parameter that I'm estimating is the difference between 2 proportions. How would I do that? And there are 2 techniques that are appropriate for it. Either a z-test to compare 2 proportions, or a 2-way table chi-square test or Fisher's exact. Those are mathematically equivalent, and it doesn't matter which one you do. We'll talk about it as a z-test because I could also do a confidence interval that way. What are the main assumptions? Well, for each group, NP and NQ is large. Another way to say that is for each group, expected frequencies are at least 5. And we always assume independence among observations. Where can I read about it? Section 10.3, or in Triola, Chapter 9. How do I do it in R Commander with EasyR? Well, I do statistical analysis, discrete variables, create 2-way table, and compare 2 proportions. Looks like this. Statistical analysis, discrete variables, create 2-way table, and compare 2 proportions. And let's say this variable with that variable. Choose the row percentages, chi-square, components, expected, turn off the Fisher's exact, and turn off the continuity correction. And you click OK. Alright, let's try another example. Team Hardly Working wants to test whether employed students have a higher GPA. So there are 2 variables there, employment and GPA. The outcome variable is GPA. It is quantitative outcome. So the input is categorical, 2 groups. And since each person is either employed or not employed, it is not repeated measures, 2 independent groups. So we've got that narrowed down to these 2 options. They're looking at the difference between 2 mu's. And we can either do a 2-sample t-test, which is simpler, or a 1-way ANOVA. They would do a 2-sample t-test, or confidence interval with the t-distribution, and we assume that each group is either normally each group is normally distributed, or n is at least 30 for both groups. I can read about it in section 10.1 or in Triola, chapter 9. Statistical analysis, continuous variables, 2-sample t-test. Looks like this. Statistical analysis, continuous variables, 2-sample t-test. Response variable would be grade, maybe that. Then you click OK. Gives you cool graphs. Let's see, maybe one more example. You've got two grueling statistics tests, and you want to know if one is harder than the other. Now we've got two variables, test score, which is quantitative, that's the outcome. The input is categorical, so I can rule out all but these, and that is test 1 versus test 2. There are only two groups, so I can rule out all but these. Since it's the same people measured twice, this is a repeated measures, also known as a paired analysis. Okay, I'm looking at the difference between the two means, the population, and this is either a paired t-test or, again, repeated measures ANOVA, the more complicated procedure. I'll do a paired t-test, and I'm assuming that the differences have n at least 30, or the differences are normally distributed. I can read about it in section 10.4, or in Triola I can read about it in chapter 9. And I do in EZR, statistical analysis, continuous variables, paired t-test. Looks like this. Statistical analysis, continuous variables, paired t-test. And then I pick time 1 and time 2, and I click OK. And that's how that works.